What's going on, guys? My name is Amos and I'm back again with another video. So in today's video, we want to continue with our implementation of AutoNlib. So in the previous video, we sort of like looked at, we sort of like implemented or defined the structure of, an automaton, how we're going to represent, this machine in memory. And this is the structure we came up with. So in today's video, we want to see how we can sort of like initialize, we want to sort of like create functions that are going to help us initialize these structures. For example, we want to initialize the alphabet, we also want to initialize the state, and then we also want to initialize the whole thing, which is the automaton. And that is going to require that we sort of like allocate memory. And so before we even do anything, we're going to, instead of like calling malloc in every function where we sort of like need to allocate memory, or calling calloc or maybe realloc if we sort of like need to sort of like resize some item, let's first of all like implement some methods that are going to sort of like help us do memory allocation. And we want to just have our own functions that will sort of like help us allocate memory. So to be able to do that, I'm going to create another header file. I'm going to create another header file. I'm going to put it here. Of course, these things might change. I might put it somewhere else, or I might do something different. I'll maybe use different functions later on. But for now, let's just first of all create a new, a new header file. So we're going to say, we're going to call it auton memory. I think auton memory is a good name. Auton memory.h, like so. So let's include our guards, right? Let's include our guards. So if not defined, so if auton memory, so I'm going to say it's auton. I'm going to go mem. I'm going to just say auton mem underscore h. If this is not defined, we'll go ahead and define the same thing. Okay. So I'm not just going to like spend time. I'm just going to like keep it, somewhere safe. Okay, so if not defined, go ahead and define that. Otherwise, you want to end if. Okay, we want to end if, and if, and not defined, like so, right? So, and maybe we can put this here, like so. So if that is not defined, we'll go ahead and define it. Now let's think about the functions that we're going to need. Let's think about the functions we're going to need. So these functions will be used, everywhere where we want to sort of like allocate memory. We could allocate memory to store, the alphabet. We could allocate memory to store, the states. We can also allocate memory to store, the automaton itself. Now, if you look at what I've said, you see that all these three things that I've mentioned are different structures. So it is here where we need to use void pointers. We need to sort of like use void pointers here. So we're going to need a function that returns a void pointer, and we're going to call it auton malloc. And by the way, all the public functions are going to be prefixed, by this auton word, so that we like know what we need. So to be able to allocate memory, what do we need? Well, we need a size, right? We need a size. We need to know. Let's first of all, let's also include stdio. Go ahead and include stdio.h. Right. So go ahead and include that, and that should work now. We also need we also need another function that is going to return another void pointer, and then we're going to call it auton calloc. So this is like our calloc. Okay, size, we need a size again of t. And I think we also need, for calloc, we also need some count, right? So we also need some count. So we also say int count, because we need to know like the number of items we want to allocate the memory for. That's how, with calloc you have to pass 2 arguments, right? So we'll sort of like use that. Right, we also need another function for that is also going to return another void pointer. We're going to call it auton, then realloc, like so. This also needs, what does this need? So we need, we'll say we'll say void, we'll say pointer. We need something that is generic. And then I think we should start with the size first. We start with the size. This is going to be like the new size because remember with Realloc, we are going to sort of like resize. We're going to resize. We're going to resize. Some entity. We'll just call it an entity. So something that is more generic, right? So we also have to pass in the pointer like so, and we'll see why I'm doing this. If it's not clear at this point, we'll see why we are doing this. Okay, we'll also need an auton free function. So void, it should take in a void pointer, should accept a void pointer. So it should accept a void pointer like so. It should accept a void pointer like so. And yeah, these I think will be sufficient for now. If we need any more functions, we'll sort of like implement them a little later. Now let's look at how we can implement these functions that we have here. So let's create a .c file. So I'm just going to call it auton memory .c like so. And the very first thing we want to do is to make sure that we include oops, not that, is to make sure that why is it doing that? So is to make sure that we include, so we are in the source directory, right? We want to grab a file that is in the include directory. So we need to like get out of this source directory and we need to go into the include directory, and we are basically looking for we are basically looking for auton memory.h. Great stuff. So that is what we are looking for, right? So we go one directory, we get out of the source folder. Okay, we go one directory up, and we get into the include directory, and then we grab the header file that we are looking for, right? So that is what we are supposed to do. Now the very first function that I want to like work on is the auton malloc function, right? So I'll just grab this, or we could have just like retyped it, and anything is possible here. So anything is going to work. So the very first thing that we want to do is to make sure that we, let's first of all, we are going to also return a void pointer here. We want something that is more generic, right? Because like I said, we'll be allocating memory for different structures and for different things. So this has to work for, everything, right? It has to work for everything. So we allocate the memory. Now, one thing that you have to do with these memory allocation functions, malloc, calloc, and realloc, is to first see to check if the memory allocation was successful. All right, is to check if the memory allocation was successful. Then outside this, we basically want to return the pointer like so, right? We want to return the pointer, but then here we have to make sure that the memory allocation was successful. So if it wasn't successful, I just want to say fn printf, then we pass in the standard error, the std error stream like so, and then we sort of like display some useful message here. We can say, maybe we can just go auton malloc to know where this problem happened. So auton malloc failed to allocate, so I'm just going to say failed to allocate space. So since it's size t, we have to do something like zu, like so, bytes, right? Z bytes, and we probably need some new line character here, and then we'll pass in the size. Right, that looks good to me, and that is all we have to do. Okay, so we save that. Now let's go back. Let's grab the second item. Again. um, same idea. I'll put it here like so. Right, so we also need to first of all allocate the memory. So pointer like so. Here we're going to use calloc like so. Now with calloc, what do we need to provide? What do we need to provide with calloc? So the first thing that we need to provide is the count, the number of items I want to allocate the memory for. And then the next item is going to be the size. Actually, for consistency, I would have like put this account as the as like the first I mean the size as the first argument, right? So okay, we might change this, but then that's okay for now. And then we also have to make sure that the memory allocation has indeed taken place. So otherwise, I'm just going to grab this, copy like so. I'm just going to throw it here like so, and then here we want to return, basically want to return the pointer like so, right? That looks good. But then here we have to say, instead of saying auton malloc, we'll say auton colloc like so. Same, but then here we have to say size multiplied by the count to get the actual amount of space we intended to sort of like allocate for whatever entity we want to store in memory. That looks good. So auton colloc failed. Okay, that's great. What else do we need to do? So we'll go back, grab this, go back, grab this, copy this, and put it here like so. Auton realloc. Right, so we pass in the size, we have a void pointer. Well, the next thing that we want to do is to make sure that we say void again, pointer. Actually, this one is going to be new pointer for it to like make sense, because we are sort of like reallocating memory to store something. So realloc, I believe it's realloc like so, right? We need to pass in the pointer again. We could have done better here, the pointer. And then we also need to pass in the new size, like so. Again, we check. So we have to check here, but then this check is going to be a little bit different. So if this doesn't work, right? If this doesn't work, and if this doesn't work, what we want to do is to sort of like, again, let me just grab this. If this doesn't work, we'll put it here, paste it, and then instead of saying auton colloc, we're going to say auton realloc, like so. And instead of size, we want to say new size, like so, and just new size here, really, just new size. Let's delete everything. Okay, we just want to say new size here, new size, like so. Great, so that works. And here we sort of like want to return the new pointer. That looks good. So we can actually add, I think, one more check here, because if this doesn't work and they've provided something that's positive, if this doesn't work and they've provided something that is positive, okay, for now that's good. So if we have any problems later on, we'll come in and sort of like fix everything. And of course, we will need the function auton free. I believe this is the signature. We take in a void pointer, and yeah, this is going to help us when it comes to like freeing entities and all that. So we just want to say free ptr like so, and that is all for this function. So it was the simplest function. Right, so let's just check what we have here. So we free it, we resize it, we allocate the memory, and then we do malloc. If we need to add anything, we'll sort of like add the implementation here and add the files, add everything in here. Now that looks good. That looks good. The next thing I want to do is to now is to initialize the different structures that we have in the different structures that we defined in the previous video. We'll start with the alphabet. Let's see how we can initialize the alphabet. Okay, so we'll need a new source file. So we're going to call it automaton dot h no automaton.c. Okay, now the very first thing that I want to do here is to go ahead and include. So we'll go one directory up. So we'll go into the source folder, into the include folder, go into the include folder, and we want to grab the automaton .h. I think we'll also need to grab the the auton memory. We'll also need to grab the auton memory. So we'll go auton memory like so. Right. So that is what we are supposed to do. Okay. Great stuff. Great stuff. So the very first function that I want to implement is, well, we sort of like have to initialize the alphabet. So we want to return a pointer to this structure. Let me go back here. We want to return a pointer to this item that we have here. So we'll say that and that, like so, and then we'll just say auton init, then we'll say alphabet. I think alphabet, yeah, that looks good, like so, right? So auton init init yeah, we won't accept any parameters or any arguments or anything like that. Now here we need to allocate memory to be able to store this. We need to allocate memory to be able to store the alphabet, and so we have to use the auton malloc function. For example, we can use the auton malloc function, for example. Now here, I'm just going to do this. We'll do something like this, and then yeah, so we'll have a alphabet. Okay, that makes sense. And we want to go is equal to auton malloc. We want to call the auton malloc function like so. We'll have to pass in the size. So here we want to do size of. Size of what? We want to do size of so here we want to do size of. If we do this is going to work. If we do size of this item, this is going to work. And then this should return a pointer. This returns a void pointer. So here we need to cast it into, we need to cast it into this, and then store it into that. Yeah. So this returns a void pointer. Remember that auton malloc is going to return a void pointer. So we need to cast it into a pointer to the alphabet, and then we'll store this in this structure here, right? Okay, that is good. We'll cast it into that, and then we want to basically make sure that, and instead of saying S here, I'm just going to say alphabet, like so. Want to say alphabet, and then here we want to say alphabet. We want to say the number of members is going to be initially 0, right? The number of members is going to be 0. So every attribute has to be initialized, and then we'll have we'll sort of like we'll have to go alphabet. The other structure here is members. Now let's remember what this is. If we go back to auton.h, we see that this is a pointer to is a pointer to an array of strings. This is a pointer to an array of strings. A dynamic array of yeah, it's a pointer to a dynamic array of strings. So again, here we have to do another auton. I think auton malloc, like so. We have to do another auton malloc, and then we'll sort of like reallocate the memory each time we want to add an item to the set. What would have done here maybe is, as we are initializing the alphabet, would have sort of like provided the number of items we want to store in that particular set, so that that is fixed, right? That's also a possible solution. Another solution is to sort of like leave it the way it is, and if we sort of like want to add something new to our alphabet or to our set, we have to like reallocate the memory. That's what we have to do. So which solution is better? Right, so we provide the size. Okay, now what I like to do is I don't like to provide arguments to my init functions, right? But then we can provide like the number of items, right? Let's change this. Let's change this. Yes, so what I want to do here is to maybe provide the size here. If I provide the size, then I'll set the size here, and then I'll allocate the needed memory directly here without needing to reallocate the memory when adding something. Okay, that's also a good solution. Okay, let's provide here, because then I know that the number of items is always going to be positive, so I'm going to go size t. Num, I'm going to say num members, like so, and I'm going to say that this is basically going to be equal to the number of members that they pass in. And then here, instead of using malloc, I'm going to use auton colloc, for example, auton colloc. And then here I'll need to provide the size. Well, for the size, we'll have to go with size of a pointer to char, like so. And then we have to provide the count. So the count is the number of members, like so, and that is going to be it, right? So we've initialized everything. We've initialized the count. We've also initialized the the members and all that. Probably have to disable this spelling checker here, because it's making me think as if I've done something wrong. And then finally we want to go ahead and return the alphabet, like so, right? We want to go ahead and return the alphabet. So that is all, that is everything that we need to do for us to initialize the for us to initialize the alphabet. And then I'll sort of like prototype these functions in the automaton.h file. That will be at the end, of course. That will be at the end. Now let's look at how we can initialize the state. So we need another function. We're going to call it init state. We're going to call it init state. Okay. Now this is going to return a pointer to a state, right? So this is going to return a pointer to a state, and then auton, then init state, like so. Right, so we'll first of all have to take in some string representation. So we need to take in the representation, and then we need to take in, we'll say int is starting state, like so. And then we need to take in an int is going to go with is ending state, like so. That looks good. Right, so let's look at our structure first before we even do anything. So where is our state? So this is our state. So we'll provide the representation, we'll provide the is starting state, we'll provide the is ending state. Then we want to set this head to no, and then the number of outgoing transitions is going to be, well, we'll do 0 for now. We'll do 0. Then each time we add a new transition to our automaton, we'll sort of like increment this number of outgoing transitions. Yeah, I think that's a better solution. That's each time we add a transition where some given state is the origin, we sort of like want to increment the number of outgoing transitions, right? So that is our proposed solution. So that is what we have now. Well, if the representation is no, if the representation is no, what do we want to do? We want to go with fprintf, then we'll provide the stream. So we'll say stdr, like so, and then we'll say, then maybe we'll do auton init init state, auton init set, state rep cannot be no. Okay, I think, yeah, that's okay. That's okay. That's okay. Right. So if everything is if everything is okay, then we have to go with string copy. But then for us to use string copy, we have to include std string. Is it string.h? I think it's string.h. That is what we have to include. So we need to copy. We need to copy. We need to copy. We first of all have to allocate memory to store the state. So we'll return a pointer. We'll return a pointer to this item, and because our function returns a void pointer, we sort of like need to cast it into. We need to cast it. That so we'll call auton. I think auton malloc. We'll call auton malloc. We'll have to provide the size. We'll have to provide the size. So here we just go with size t. We'll have to go with the size of a state nodes, like so. Oh, not size t, but we want to go with size, I think, of. Yep. Yeah, that is what we have to do. Size of that. So we do the casting into that. Or we have to provide the name here, of course, otherwise it's not going to work. So state, like so, that looks great. So we need to copy. So here, because this is a pointer, we need to copy into this whatever we pass in as the string, as the representation, right? We have to copy whatever we have there. And then here we have to say state. Then we have to set the starting and the ending state. So if it's we need whatever we pass in as a starting state is starting, like so. And then we'll go with state, like so is, and then whatever we pass in as the ending state, that's a bit too much. Whatever we pass in as the ending state, so is ending state. Okay, and then what other things do we have to initialize? And this is not very clear. Instead of saying head, here I'll say transitions. If I say transitions, yeah, that makes sense. I'll do transitions here. And then here I'm going to say state transitions. Okay, it reflects. And then we'll set it equal. This is going to be no, right? Remember, this points to the head of a linked list of transitions. And then the number of transitions, we're going to say state dot out transitions, the outgoing transitions, we want it to be 0 in the beginning. And since this returns a pointer to state, so we have to go with state, like so. Okay, yeah, that works. That works. That works for me. Okay, the next thing that we have to do here is to initialize our automaton, right? That's the next thing that we have to do. That's the next thing that we have to do. That's the next thing that we have to do. Okay. Just looking at things here to make sure that everything is okay. Okay, great. So to be able to initialize the automaton, we need to provide the number of states, I think. So let's say here we want to go with a automaton t, like so. This returns a pointer, and then here we want to go with auton init automaton, like so. And then we need to take in the number of states. So here we'll say state count, states count. Is it states count or state count? Okay, whatever. So that, and the very first thing that we want to do here is allocate memory. So we'll say automaton t, like so. This should return a pointer. Then here we do the casting thing. Okay, we do the cast, like so, because it returns the function that we're about to call returns a void pointer. We cast it into that, and we need to provide the size. And so here we should say size of this item, a, and then this. How does that look? So yeah, so that looks okay. And of course we have to, like, provide the name here. I'm just going to call it automaton, the full thing. Okay, the error should like go away. Okay, that is what we have. The next thing I want to do is the next thing that I want to do here is to like initialize the alphabet, because we have to initialize everything that we have here. If we like go back here, let me just save this. We have to make sure that we initialize everything. Okay, so we have this and this. Okay, and then I think for the alphabet, for the automaton, but then if we provide the size here, then we also need to provide the size of the alphabet here. We also need to provide the size of the alphabet here. I think that's good. Okay, let's go int alphabet. Oh, int alphabet size. I think that's okay. That's okay with me. So let's go. Then we're going to go with alphabet, like so. Then we're going to say init. It's like it's auton init alphabet. Then this requires a size, so we're going to pass in the alphabet size, like so. That should initialize the alphabet. That should initialize the alphabet for us. Okay. Okay. Then the states, we need to allocate memory to store the states. Now that should be simple. Again, we have to just do auton auton, and then we should go states. We have the number of states that we want to store, and so we should call, I think we can do colloc here. We can do colloc. We can do colloc. This is a dynamic array of states. So here I want this to be, we want to cast this into this. We want this to be cast into, it's a dynamic array of states. So we do something like this. Okay, we do something like this, and then we'll do auton colloc, like so. We need to pass in the size, and then this is supposed to be the size. We'll do size of a, and then state pointer, like so, because every state is a pointer, and we'll pass in the count here. The count is going to be I think the number of states count. Okay, that looks good. Right, let's just make sure that everything is okay. Okay, so we have the alphabet, we have the states. The only remaining thing is what colloc does for us. It sort of like initializes the spaces for us, everything for us. Now, because I want to show you what you're supposed to do, with let's use colloc first of all. Let's do colloc and then do the looping ourselves, right? And then do the loop ourselves. So we can leave it the way it is, or we can because every space is going to be is going to be initialized for us with by this colloc function. Okay, if we have any problems, we'll come back and fix everything. And I think we've not set the number of states. So num states is going to be equal to states count. I think states count like so. And finally, what we can do is that we can return the automaton. Okay, I think that looks good. Let's just check. So we have the number of states, the alphabet, and then the states. Okay, that looks good. That looks good. So we've initialized the automaton, we've initialized the state, we've initialized the alphabet, and maybe something that I really should have done in automaton.h is to okay, we'll do it. Then we need to prototype these functions. So here we're going to copy this, and then we're going to go back here, put it here like so, and we should include something. we should include something here. Include stdio.h. That should get rid of the error that we are seeing here. Okay, took a lot of time to like get rid of the error. Let's grab this, copy this, put it here. Okay, I think that looks good. We save that. How do I even disable this spelling checker? So I'll disable it because it's pretty annoying. So put it here, right? So we've prototyped all the functions. And everything looks good. And what we should have, maybe done here is, I'll go back to this is if the allocation fails, if the memory allocation fails, we don't want to continue, right? Because this is like a critical section. So we need to maybe exit and then say exit, I think exit failure, like so. Is it exit failure or something? Exit failure. Do we have the standard library here? I don't know. stdio. Is it in stdio? Is it in stdio? Is it in what? Let me just Google this. Exit failure, because it says, or is it the spelling that is not correct? I believe it's exit failure. It's exit failure lib library in C. I think it's exit failure. Exit failure. Ah, we have to do stdlib, I think. Stdlib. Does it go away now? There's the error. Oh yeah, it does. So exit and copy that and put it here. Put it here also, like so. Yeah, and that should work. Okay, so this is what we have. Let's go through. So we've initialized the alphabet, we've initialized the states, we've initialized the automaton, and in the next video what we're going to do is we're going to like work on the functions that are going to allow us or help us to free the memory that we've allocated to store the automaton, because it's very important, and also the memory we've used to sort of like store the states, and of course the memory we've used to store that. Okay, so in the next video we'll do that, and we'll test everything that we've like worked on so far. We'll test everything that we've worked on so far. So we have a header file where we've defined the structure for our automaton. All the public functions are going to be prefixed with the name, the first part of the of the name of the alphabet, and the name of the function. Okay, so yeah, we have the structure, we have the functions, and then we have memory allocation functions here, and then we have their implementation. Here. Okay, thank you guys for watching, and I'll see you in the next video.